welcome to my channel. Today's topic is exponent. What are exponents? In mathematics, an exponent or exponents are numbers that look generally at this. A. 8. This is an exponent. An exponent is a number that looks generally like this. Where A, which is the random number, is known as the base in mathematics, and 8, which is the small number, is known as the power. So in other words, the random number in an exponent is known as the base, while the small number in an exponent is known as the power. A type of exponent includes this. These are exponents because each of these numbers look similar to this general number. Each of these numbers look similar to this general number. Now, how are these numbers pronounced? Or in general terms, how is this pronounced? How is this pronounced? Now, this is pronounced as A to the power of 8. This is pronounced as A to the power of 8. Yes, this is pronounced as A to the power of 8. Or A to the 8th power. So that's how it was this pronounced. A to the power of 8 or A to the 8th power. So this is pronounced as A to the power of 8. This is pronounced as 2. Wait, 2. To the power of 2. This is pronounced as 3 to the power of 4. 6 to the power of 9. 7 to the power of 2. 8 to the power of 7. That are exponents are pronounced. I told you an exponent is a number that looks generally at this. A to the power of 8 as it is pronounced. Why the bigger number, which is A, is known as the base. The small number, which is 8, is known as the power. Now there's something about exponent. The power of a base always keep how many of the base are multiplying to theta. The power of the base always keep how many of the base are multiplying to theta. That one very unique. This one unique beauty of exponent. The power of the base always keep how many of the base are multiplying to theta. Yeah, that's one thing about exponent. The point that 2 to the power of 4. 2 is the base, while its power is 4. So therefore 4 is the power of 4 is the power of 2. 4 is the power of 2. 4 here tip how many 2? 4 here tip how many 2 are multiplying each other. 4 here tip how many 2 are multiplying each other. So which means that this 4 is the power. 4 is the power. It means that there are 4 2 that are multiplying each other. Yet this 4 is the power. It means that there are 4 2 that are multiplying each other. So writing it in a expanded form, you have 2 times 2 times 2 times 2. Why? Because the power of 2, which is 4, how many 2 are multiplying each other. Another one, pipe to the power of teeth. Pipe to the power of teeth. Now teeth, pipe is the base here, while its power is teeth. The type of teeth is the power of pipe. Teeth here, deep, how many pipes are multiplying each other? Teeth here, deep, how many pipes are multiplying each other? So therefore, teeth here means that teeth pipe are multiplying each other. And writing teeth in a pattern form, you have pipe, tant, pipe, tant, pipe, tant, pipe, tant, pipe, tant, pipe. So with all teeth printed and with all teeth printed, exponent in mathematics, exponent is also known as repeated multiplication. Yes, all dependent exponent in mathematics is also known as repeated multiplication. And how are they related to multiplication? Because both exponent and multiplication are deal with the term repeated. In mathematics, exponent is known as repeated multiplication. Just as multiplication is known as repeated addition. Just as multiplication is known as repeated addition. Now we will deal with something known as the word of exponent. The word of exponent. Now what are the words of exponent? Now the word of exponent are the roots that topping exponent. The word of exponent are the roots that topping exponent. So without further ado, I will teach you two words in this video. And these are the multiplication word and the division word. The multiplication word and the division word. Also, there are 8 words of exponent, but I will be taking them step by step. I will be taking them step by step. But in this video, I will be teaching you two words. Multiplication word and the division word of exponent. Now multiplication word. Other multiplication word. If two exponents with the same base and different powers are multiplying each other, therefore one of the base will be raised to the power of the power. They will be raised to the power of the powers adding each other. Yet, if in order to multiplication word, if two exponents with the same base and different powers, if two exponents with the same base but different powers are multiplying each other, then it will be equal to one of the base with the powers adding each other. Will be equal to one of the base with the powers adding each other. Therefore, in multiplication word, multiplication is known to tend to addition at the end. In multiplication word, multiplication is known to tend to addition at the end. Division word. Under division word, if two exponents with equal base but different powers are dividing each other, if two exponents with equal base but different powers are dividing each other, then equal to one of the base with the powers subtracting each other. Then it's equal to one of the base with the powers subtracting each other. So therefore, in division word, division is known to tend to subtraction. So not it. In multiplication word, multiplication is known to tend to addition, while in division word of exponent, division is known to tend to subtraction. I have taught you what exponents are and how they are related to multiplication. I also taught you the two words of exponents, which are the multiplication word and the division word. And I have made some examples under this word. Now the best example is that I do to simplify 10 to the power of 2 times 10 to the power of 3. The second example states that to simplify m to the power of 8 divided by m to the power of 5. While the third example states that to simplify a to the power of 9 times a to the power of 3 times a to the power of 5. Simple. Now for the first example, for me to simplify 10 to the power of 2 times 10 to the power of 3, I do note that there are two exponents multiplying each other with different base for different powers, and the multiplicator rule, if a to the power of 8 is multiplied by a to the power of y, two exponents multiply each other with different base for different powers, then it will be equal to one of the base with the powers adding each other. So using the same method we are applied here, I'm applying it to here. We have 10 to the power of 2 times 10 to the power of 3. Apply what is keeping here to here. We have 10, pick one of the 10. With the powers 2 and 3 add each other, 2 plus 3. So which equal to 10 to the power of 5. 10 to the power of 5. Example 2. Simplify m to the power of 8 divided by m to the power of 5. Now this one is due to the division rule. And under the division rule, if a to the power of 8 is divided by a to the power of y, two exponents with the same base for different powers divide each other, it will equal to one of the base with the powers subtracting each other. So using the same method given here, m to the power of 8 divided by m to the power of 5 is equal to m to the power of 8 minus 5, which is equal to m to the power of 3. Note that this is also the same as this. That's the same thing. Don't wait time computer. It also a division time. Example 3. Now example 3 seems more tricky to use that, but don't worry, it is very simple. Simplify a to the power of 9 times a to the power of 3 times a to the power of 5. Now this is the multiplicator rule. But when I will teach you multiplicator rule, I only take 2 exponents, not 3. But that don't matter. Since the exponents that are multiplying each other have the same base for different powers, the multiplicator rule will still work. Therefore, this is equal to a, picking one of the a, to the power of 9 plus 3 plus 5. Why? Because the exponents that are multiplying each other have the same base for different powers. So you pick one of the a with the powers adding each other. So this is equal to 9 plus 3, 11. No, 9 plus 3 is 12. Yes, 9 plus 3 is 12. 12 plus 5, 13. So we have a to the power of 13. A to the power of 13.